The technology adoption life cycle is a sociological model that describes the adoption or acceptance of a new product or innovation, according to the demographic and psychological characteristics of defined adopter groups. The process of adoption over time is typically illustrated as a classical normal distribution or bell curve. The model indicates that the first group of people to use a new product is called innovators, followed by early adopters. Next come the early majority and late majority, and the last group to eventually adopt a product are called laggards. The demographic and psychological or psychographic profiles of each adoption group were originally specified by the North Central Rural Sociology Committee, Subcommittee for the Study of the Diffusion of Farm Practices, by agricultural researchers Beal and Bolin in 1957. The report summarized the categories as 1. Innovators, had larger farms, were more educated, more prosperous and more risk-oriented. 2. Early adopters, younger, more educated, tended to be community leaders, less prosperous. 3. Early majority, more conservative but open to new ideas, active in community and influence to neighbors. 4. Late majority, older, less educated, fairly conservative and less socially active. 5. Laggards, very conservative, had small farms and capital, oldest and least educated. The model has subsequently been adapted for many areas of technology adoption in the late 20th century. The model has spawned a range of adaptations that extend the concept or apply it to specific domains of interest. In his book Crossing the Chasm, Geoffrey Moore proposes a variation of the original life cycle. He suggests that for discontinuous or disruptive innovations, there is a gap or chasm between the first two adopter groups, innovators/early adopters, and the early majority. In educational technology, Lindy McKeown has provided a similar model, a pencil metaphor, describing the ICT uptake in education. In medical sociology, Carl May has proposed normalization process theory that shows how technologies become embedded and integrated in healthcare and other kinds of organization. Wenger, White and Smith, in their book Digital Habitats, Stewarding Technology for Communities, talk of technology stewards, people with sufficient understanding of the technology available and the technological needs of the community to steward the community through the technology adoption process. Reyna and Strukova 2009 proposed that the choice of initial market segment has crucial importance for crossing the chasm, as adoption in this segment can lead to a cascade of adoption in the other segments. This initial market segment has, at the same time, to contain a large proportion of visionaries, to be small enough for adoption to be observed from within the segment and from other segment, and be sufficiently connected with other segments. If this is the case, the adoption in the first segment will progressively cascade into the adjacent segments, thereby triggering the adoption by the mass market. One way to model product adoption is to understand that people's behaviors are influenced by their peers and how widespread they think a particular action is. For many format-dependent technologies, people have a non-zero payoff for adopting the same technology as their closest friends or colleagues. If two users both adopt product A, they might get a payoff of less than 0. If they adopt product B, they get B greater than 0. But if one adopts A and the other adopts B, they both get a payoff of 0. A threshold can be set for each user to adopt a product. Say that a node V in a graph has D neighbors, then V will adopt product if a fraction P of its neighbors is greater than or equal to some threshold. For example, if V's threshold is 2/3, and only one of its two neighbors adopts product A, then V will not adopt A. Using this model, we can deterministically model product adoption on sample networks.